right, so we are going to be talking about algebraic expressions today. And when we're talking about expressions, we're going to be looking at expressions and equations. So when I'm talking about expressions, my pen is not liking me today. When I talk about expressions, an expression is just a statement on its own. So like 2x plus 4. An equation involves an equal sign. So in this example, I could say 2x plus 4 equals 6. Right? 2x plus 4 equals 6. This is an equation because I have an equal sign. So equations have equal sign. Expressions are just by itself. So we're going to look at simplifying expressions and then also solving equations. We have a couple of vocabulary terms to look at. The first one is like terms. Okay, so when we're talking about like terms, if we look up here, in my 2x plus 4 example, I have two terms in this example. I have a 2x and I have a 4. Those are my two terms. So a term is either a constant, so my constant is a 4, right? That can be a term. So it's a constant, or it's a variable raised to the same power. I'm going to show you what I mean. So if I have, let's say, so my like terms I said are constants. So my 2x could be a term. Let's say I have the term 2x, okay? Another term that would be a like term to 2x could be 4x. Could also be 7x. Could be 1/2x. All of these are like terms because they have a variable x raised to the same power. So in this case, with x by itself, each of these x's, each of these variables have a power of 1. We just don't write it because it doesn't matter, right? Anything raised to the power of 1 is just itself. Okay, so all of those are like terms. Similarly, I could have like 2x squared. I could have, let's see, like 3x squared, right? 3/4 x squared. Okay, all of these are to the same power. They have the same, they're raised to the same power. And so all of these would be like terms as well. So my constants are like terms. And then I would have x squared, x cubed, x to the 4th, and so on and so forth, right? These are my terms, right? My like terms. Okay, and then when we're talking about simplest form, if I'm going to write something in simplest form, there's no like terms left. There's no like terms left, no parentheses. And you can't combine anymore. Can't combine anything else. Okay, simplest form. I can't combine anything else. So my 2x plus 4 is an example of that. I don't know why that keeps writing up here and there. 2x plus 4 could be an example of that. 3x squared plus 7x plus 3, right? That could be in simplest form. I can't combine any of those. So simplest form is when we have combined things as much as we can. We can't combine anything else. That's simplest term, or simplest one. The last one then is inverse operations. So inverse operations, what they do is they cancel or undo each other. And if we think about this, undo Okay, if I add 7 to something, the way that I undo that or get rid of that is I subtract 7, right? Same thing as if I multiply something by 2, the way that I undo that is I divide it by 2. So my inverse operations are addition and subtraction, and then multiplication and division. They cancel or undo each other. Okay, that is all of our vocab. And so when we are simplifying an algebraic expression, there's a couple things that we need to remember, okay? The first thing that we need to remember is to combine like terms first. I want to simplify it as much as I can before I do anything else to it. So simplify, right? That's what that means. Simplify as much as you can. Combine like terms first. Once you have combined like terms, then you need to use your inverse operations to solve. And we'll take a look at that here in a second. So first I need to combine like terms or simplify it. Second thing I need to do is use inverse operations to solve. The last thing that you need to keep in mind is to keep it balanced. So what I mean by that is what you do to one side, you have to do to the other side. What you do to one side, you need to do to the other. So, in my example up here, I did, I think, 2x plus 4 equals 6, right? Well, I want to get this x by itself. I want to isolate it so that I can work with it, right? And so the way that I would want to do that is, well, like, I want to get rid of this 4, right? Well, if I get rid of 4 from this side, that changes, and I don't do anything to this other side, it changes the equation. Now it's 2x equals 6, but that's a different thing. That's not the same equation as what I'm talking about. So if I get rid of the 4 here, I need to get rid of 4 over here, which means that this changes to 2x equals 2, right? Because I subtract 4 from both sides. I have to keep it balanced. We are going to practice a couple here. So 8 plus x equals 12. I need to get x by itself. The way that I'm going to do that is by subtracting 8 from both sides. Do you see how I'm writing minus 8 on both sides to remind myself that I'm keeping it balanced and I'm showing my work? So then I'm just left with x equals 4. I'm done. That's it. The next one, m plus 15 equals 6. I'm going to subtract 15 from both sides. I'm left with m equals 6 minus 15 is a negative 9. This next one has one extra step to it. So first I want to get rid of this 12 because I want to get my y by itself. So I'll subtract 12 from both sides. Then I'm left with negative y equals negative 14. Now, am I done? I'm not done because I have not gotten y by itself. And the reason why I've not gotten y by itself is that we can imagine that there is a 1 in front of our variable here. So like over here, I have 1m, 1x. So this is a negative 1y. But the thing is, I just need to get it down to 1 something, not negative 1 something. And so I need to get rid of this negative 1. Well, I'm multiplying negative 1 times y. So in order to get rid of that, I can divide both sides by negative 1. So then I'm just left with y equals a positive 14. And that's my answer. Okay, this next one, 4r equals 32. 4r means that I am multiplying. So to undo multiplication, I need to divide both sides by 4. Whoops. I'm going to divide by 4. This side doesn't like me over here. So So then I'm just left with r equals 8. W over 2 equals negative 10. That means that I'm dividing W divided by 2. So to undo division, I need to multiply. So I'm going to multiply both sides by 2. I'm left with W equals negative 20. Our last one over here, I've got Q divided by 6 equals 1. I'm dividing, so the opposite of that is multiplying. I'm going to multiply both sides by 6. I'm left with Q equals 6. All right, next page. Here, we're going to evaluate each algebraic expression when x equals 0 and x equals 1. We're going to use our results to match each expression on the left table with its equivalent expression on the right table. So this left table is not simplified. Okay, and this right one is simplified. So we need to figure out which ones belong together, and we're going to use their values to do that. So let's look at this first one. This first one, I've got 3x plus 2 minus x plus 4. I need to evaluate first when x equals 0. So I'm just going to plug 0 back into my equation. 3 times 0 is just 0, right? And then I'm going to put a 0 over here, 2. So now I've got 0 plus 2 is 2, minus 0 is still 2, plus 4 gives me 6. Now I'm going to do the, 6. Okay. Oh, I did it again. Okay, so now we're going to do the same thing, but with x equals 1. Get rid of that. Okay, so here I'm going to have a 3 times 1, which is just going to give me a 3. That's going to change to a 1. 3 plus 2 is 5. 5 minus 1 is 4. 4 plus 4 is 8. When x equals 1, my equation equals 8. Then this next one, if x equals 0, that means that 0 minus 3 is a negative 3. Negative 3 times 5 is negative 15. Negative 15 plus 2 is a negative 13. When x equals 1, if I put a 1 here instead, 1 minus 3 is negative 2. Negative 2 times 5 is negative 10. Negative 10 plus 2 is going to give me a negative 8. Okay, and then I'm going to do a couple over here too, and then I'll have you do the rest on your own. So my expression here, this may feel a little bit confusing. So I have my expression is 4. Are there any x's in this expression? No, there are not. So when x equals 0, this is still 4. When x equals 1, this is still 4. It's 4 either way. Letter B, when x equals 0, I've got 0 plus 1 is just 1. And then when x equals 1, I have negative 1 plus 1 is 0. Okay? What I would like you to do is pause this now, complete the table on your own, and then come back and check your answers when you're finished. All right, when you got finished, you should have gotten these as your answers, and then if you look at which of these coordinate with the simplified versions, I have the letters over here. So if we even look at this first one, letter A, 3x plus 2 minus x plus 4, that coordinates to D over here. And if I look at this, I've got 3x minus x gives me my 2x. Whoops. Gives me my 2x. And then I've got 2 plus 4 equals 6. Right? So this is the simplified version of that. So then the last thing here is we're going to compare each expression on the left with its equivalent expression on the right. And in general, how do we obtain it? Well, we just looked at that, right? How did we get from 3x plus 2 minus x plus 4 to 2x plus 6? We combined like terms, right? Combine like terms and simplify. Alrighty, and that is all for 3.1.